It's no surprise for anyone who's had 5+ decades on their biological resume that memory is just not what it used to be when you were younger. And for all those youngins going, psh, yeah, we'll see, the data just isn't on your side. In fact, memory is often one of the first noticeable cognitive things to go. That is, if you don't proactively and consistently tickle the brain cells that support it, which is exactly what this new groundbreaking study displayed how to do. Let's check it out. Yo, yo, yo! What is up? Welcome back to another week of How to Health. My name is Kevin. I run liftandbalance.com, where we take aim at all things health and longevity and do it in an odd, weird, interesting, and highly sarcastic way. Listen, we all know exercise is powerful, and I think the best piece of evidence that supports this is the fact that despite the extraordinary levels of discomfort, suckiness, and mental suffering that it can induce, we continue to come back to it. Day after day, week after week, year after year, both scientifically and in our everyday life, because it works in ways nothing else does. And that's just a testament to how powerful of a biological modulator it is. One of the beautifully ironic parts being the fact that it is also one of the best ways to overcome that mental suffering. Yeah, suffering acutely to avoid suffering chronically. And all of this has been pretty clear in the data for decades, as epidemiological and observational studies have consistently highlighted the beneficial associations between regular physical activity and improved brain health, including a reduced risk of cognitive decline and onset of cognitive diseases such as Alzheimer's, which, if you weren't aware, is characterized by the literal deterioration of neurons in key areas of the brain, such as the learning and memory center, the hippocampus. That being said, despite us knowing that exercise clearly has an impact, and likely a profound one here, a fundamental knowledge gap continues to persist. In particular, between this beneficial association and the precise cellular and molecular mechanisms through which this badonkadonking exercise exerts its neuroprotective effects. And that's exactly what this new study sought to explore. And if you remember anything from this powwow, I want you to remember this. Exercise doesn't just help the brain, it changes it at the cellular level. And here's how. Researchers out of Mass General Brigham turned to a mouse and human model to explore and identify the specific brain cells that respond to exercise the most, and delineate the molecular changes occurring within these cells to uncover the specific mechanisms at play. I know. No simple task. And to do this, they first experimented on a model of mice who were genetically predisposed to have an early onset of Alzheimer's, which is characterized by a rapid cognitive decline and atrophy in key regions of the brain, like the aforementioned hippocampus. And after living their first 7 months in normal lab conditions, they split the mice into two groups. One which got on the exercise wagon, performing a 60-day regimen involving frequent freewheel running, something most mice love to do, and compared it to the second group which acted as sedentary controls, which in people terms would be those couch potatoes. And to get granular, the researchers used cutting-edge single-nucleus RNA sequencing to map out how physical activity affected specific brain cell types across these two groups, performing detailed biopsies of the hippocampus after the interventions to see what was really happening under the neuronal covers. And that right there is exactly why this needs to be a mouse model, because we just can't do brain biopsies on people for normal research. It's simply way too invasive, risky, and dangerous, and ethic boards would never approve the study design. So, mice it is. With that, what'd they find? Well, first off, on the behavioral front, there was a significant improvement in memory in the exercise group compared to their sedentary counterparts, which reiterates the aforementioned mountain of associational data collected over the years. However, that's just the table stakes. The real interesting findings happened at the molecular level. Here, the RNA sequencing revealed that exercise elicited distinct transcriptome responses, meaning changes in genetic expression which varied significantly between the exercise and control groups, with the most prominent and impactful changes observed within immature neurons. Pretty cool. But the juicy findings actually occurred in the non-neuron cells, as exercise restored the transcriptional profiles of a significant proportion of genes that were abnormally expressed in a bunch of key brain cells that don't normally get a lot of press, starting with microglial cells, which we conveniently have a whole video on here. That's how important they are. These are the brain's resident immune cells, which play a complex and often detrimental role in neurodegeneration. However, the researchers here observed an advanced gene expression profile as a result of exercise, suggesting a shift to a more beneficial modulation of neuroinflammation and an overall protective phenotype. You don't say. What else? Next, they saw a shift in a very important blood vessel supporting cell called neurovascular associated astrocytes. And if you recall anything about cerebral blood flow from this breakdown here, it is the literal lifeblood, pun intended, of our metabolically demanding brain. And these specific cells provide metabolic and structural support for neurons, regulating synaptic function and maintaining the integrity of the blood-brain barrier and all of the supporting blood vessels in the brain. Rather important if you ask me. The key discovery here being that the abundance of these neurovascular astrocytes was reduced in the Alzheimer's disease mouse model, but their specific gene expression signatures were dramatically induced or upregulated as a result of exercise. Pretty damn interesting. I know, but there's more. The next supporting cells that they observed changes in were in the ones that are responsible for producing the myelin protective barriers which house the axons of neurons, oglial dendrocyte progenitor cells, which were the cells that exhibited the highest proportion of Alzheimer's dysregulation genes that were successfully recovered or normalized by the exercise intervention. A good sign indeed. And finally, the researchers also identified some enhanced signs of neurogenesis, or the creation of new adult-born neurons, a topic we talk all about in this video here, specifically observing that the metabolic gene ATPIF1, a key player and potential driver in promoting neurogenesis, had one of the most prominent transcriptome responses to the exercise intervention, highlighting exercise's potential in regenerating and restoring a damaged brain, which is super promising, but also something that we need much more research on to further clarify. And remember, all of this was done in mice, not humans. And in reality, the results from most mouse models do not typically translate one-to-one with humans. And although the researchers in this study were not able to do the same detailed controlled experiment and analysis in humans, they were able to do some cross-correlation, specifically by leveraging a large independent data set of human Alzheimer's disease brain tissue analyzed with the same single nucleus RNA sequencing. Here they were able to validate that many of the observed cell-specific responses and gene activity patterns they saw in this mouse model were also relevant in humans, establishing a vital step which significantly strengthens the translational relevance and human applicability of these studies. Pretty cool, I know. But much more work is needed. And while that work's being done, here are some practical takeaways that you should start noodling on here and now. And if it isn't obvious, and if you're not doing it, the first thing is to move your ass, and move it early and often. In life, that is. But you already know that because you've been through all of our exercise-focused deep dives, breaking down how it is literally the closest thing to a magic potion for cellular and metabolic health and thus longevity that exists. Right? Right. So if you're just starting your movement journey, this video on how you can sneakily add more movement into your day is a great place to start. And if you've been at it for a while, hell yeah, keep rocking on. And I'd love to hear your go-to approach for training for life in the comments below. And if you want to see mine, you can check out this training for longevity video, which I'll drop in the show notes below. That being said, the most important thing to remember, memory, pun intended, is that moving your badonkadonk may not only be preserving your cognitive and neuronal health, it could very well be having a decline reversing effect at the cellular and molecular level, which is a whole nother ball game. Because as we saw in this new study today, by actively restoring healthy gene expression profiles in key cell types, modulating critical cellular players like microglial and neurovascular associated astrocytes, and promoting neurogenesis, exercise appears to profoundly enhance the brain's intrinsic capacity to resist and recover from pathological insults associated with aging. Reiterating once again, but now with more mechanistic details, that proactive exercise is a cornerstone in extending health span, or truly healthy years of life. Those years free of debilitating chronic diseases, the scariest one of all being neurodegeneration. Doing this by preserving a high level of cognitive function and independence well into advanced age. And that is a beautiful thing to know. A beautiful thing that only happens if you move your beautiful thing. So let that be your motivation to get up today and move your ass.